Alright, so first thing first, we are going to understand about the data, and we'll talk about what are the data types which you will encounter when you deal with any kind of statistical problem or numerical problem in data science or in machine learning, and your methods of applying any kind of analysis will heavily depend upon what kind of data you will have. So it's one of the most important and basic thing which you need to understand. So first thing first, we'll talk about what is data and how to define the data and what are the different types of data we have. So we'll talk about data. First thing, what is data? Data is in context of computing, refers to distinct pieces of digital information. Data is usually formatted in a specific way and can exist in variety of forms such as numbers, text, or there are other various types like strings also. And sometimes in machine learning you also use data as pictures. So anything which is digitally recorded and there are different pieces of that information which is recorded can be called as data. And in some of the cases you will find that the data and the information are the two terms which are used interchangeably, right? Which means that somebody can say that I have got some information, or somebody will say I have got some data, but there are differences between data and information. Data could be anything. It could be anything which is recorded. For example, how many people are passing by from a certain road, how much you earn in a day, or how much time you spent on a certain project. It could be any information. It could be any data. It could be anything which is recorded. However, if you take out some important piece from that data or something which is useful, then you will call it as information. Information is always extracted from the data, not from anything so there you can't use data and information interchangeably. However, people do that often. For example, you might have noticed that there are people who talk a lot, right? And then they are explaining you certain things, but there are only one or two lines which are important for you to understand. So or whatever they say, you recorded them, and then you pick up only one or two lines from them, from that particular speech or the text. Then it is called information. Information is always whatever you extracted from the data, so you can't use them interchangeably. Now what we're going to understand is the different types of data, right? And then we also understand how statistics is leveraging the power of data. Okay, so what is statistical data? The collection of data that are relevant to the problem being studied is one of the most common, difficult, expensive and time-consuming part of the entire research project. So you picked up a problem, and then to solve that particular problem, you start gathering the data. You start gathering some information, some key features about a certain problem, certain measurements. This is called statistical data. When the problem is closely related to just when you understood the problem, the whole data is gonna talk about that problem, right? What are the different possible ways in which you can analyze that problem. You will collect data for that particular problem. This is called statistical data, wherein I have identified a problem, and to solve that problem I start gathering the data, and I call it as statistical data. And it's one of the most time consuming part of the entire research project. And even for your machine learning algorithm, when you deal with data, it's the most crucial thing is that how to manipulate the data in the right way, how to collect the data in the right way, what are the things which you require in order to solve a certain problem is one of the most important feature. And then we'll talk about it, how to manipulate the data in upcoming videos. Now the whole statistical data can be divided into two parts. Like when you start collecting the data, there could be primary data, there could be secondary data. Now, the primary data are collected specifically for the analysis which I am looking for. For example, I want to find out how many people will buy a certain product when I launch it on any online portal or e-portal, wherein like people like Amazon or Flipkart. I want to understand how many people will particularly click on this particular advertisement or buy a specific product. And I'm collecting data for that, right? This is my this is called as primary data. Now then we have secondary data, which is when I compile this primary data and take out inferences from it, and then I convert that into a specific analysis, then I call it as secondary data, which is could be at times the extraction of from the primary data or raw data. This kind of data can be used for a certain problem, not for any other problem. For example, I want to find out how many people will click on this advertisement and how many people will buy that particular product after clicking on that advertisement. So my primary data is that how many people, when I launch a product on my portal, how many people click on a certain thing. This could be my primary data, and out of which I can find out the probability of how many people will click on a certain product. But after clicking on that product, they will click on the buy now button as well, or they will buy a certain thing. That could be my secondary data. But this kind of analysis will not be used in any other kind of analysis. So secondary data may or may not necessarily depends upon the problem which you have defined initially. Secondary data is very specific to a particular solution, and you can use secondary data only for a certain problem, not for any other problem. However, primary data will comprise of everything which is related to that problem. Now again, the data could be of other types also. In a certain project, you can have two other kind of data, which is variable and constant. I'm sure you must be knowing the difference, but just to clarify, variable would be any item of interest that can take many different numerical values in a certain project, and constant will always have a numerical fixed numerical value. It will not change in a particular project. It may change in other projects also, but for a particular program or a statistical analysis, that value will remain constant. Then you call it as a constant value. The most important thing about the data, which can be which you need to understand, is that their data can be of two types. One is qualitative data, and the second is called quantitative data. Now, the qualitative data is more of qualities, information that cannot be expressed or measured on the number scale. For example, my hair are black and your hair are gray. You cannot quantify the black and gray on the numerical scale, right? What would be the number of black, or what would be the number of gray, right? This is called qualitative data. And I can say that this guy is much more funny, or I can say this guy is having good funny behavior than any other guy, right? I cannot define that on numerical scale, right? There are certain data where you cannot define the numerical scale, right? And this kind of data is called qualitative data. The second kind of data is called quantitative data, which is measured on a numerical scale. For example, number of people, the distance covered, salary offered, or earning in a month, or how many times I'm working on a project. Everything which can be measured, which can be quantified, which can be performed on a numerical scale and can be measured on a numerical scale, is called quantitative data. Now this qualitative data, which is generally described by word or letters, right? They are not widely used as quantitative data, because sometimes we and most of the times we use numbers to define certain things, but numerical techniques do not apply at all to qualitative data, and that's where you need to be very much cautious, because you can't take average of qualitative data, right? You can't just define the values of the qualitative data. They can be only represented in the number of times they are occurring, which means the frequency of occurring or something like that, right? So for example, if I want to find out the average hair color, or I can find out the average blood type, or this will not work, right? I cannot take average of, I cannot apply numerical analysis on qualitative data. So at times, and then when you dig in deep, right, in the qualitative data, the qualitative data can be of two types, right? One is called dichotomic and the second one is called polynomic. Now in certain data sets you will find, or in certain types of problems you will find, that there are only two possible outcomes, right, which are possible. Like for example, I would say whether this person is dead or he's alive, right? You have only two options available. Whether this person is male or female, there are only two possible options. When I can say that whether bank will approve my loan or not, whether I got the loan or not, have I reached on time or not. So there are certain problems where only two possible options are there. There is no possibility of the third option. These kind of data sets are called dichotomic, wherein you can have only two possible values as an output. Then we have something called as polynomial data, which is again a part of qualitative data, which takes, they can have multiple options, right? They are still qualitative, but they can have multiple possible outcomes. For example, the education, right? You have primary school, secondary school, and university. You can't take average of them, but they can be described in various forms, and then there are various possibilities. Somebody is graduate, somebody is postgraduate, somebody is having the elementary school education, or so on and so forth. Average skin type cannot be defined over here. However, there could be possible options, right? You can have multiple skin type, you can have multiple diseases, right, which can be described in 1, 2, 3, 4 scale, but you can't take average of them, right? So you can have qualitative data wherein you can have the possible outcomes or the possibilities of having multiple things is more than two. You call them as polynomial data. The most important, quantitative data. Quantitative data are always numbers and are the results of counting or measuring attribute of a population or any kind of the area of study, right, wherever you want to study. So even then, quantitative data can be divided into two parts. One is called discrete, where you have the results of counting. When you say I want to count some number of people, number of kids in a particular family, number of people in a particular family, number of classrooms, number of classes attended, all these things, when you are counting the numbers, are called discrete data. You cannot have 1.5 classes or 2.5 people in a house. Either it could be 2 or it could be 3. So you are counting those numbers. So this is called discrete data. Then you have continuous data, right, which is the result of measuring something, how much distance you have traveled, weight of a luggage, age of a person, could be salary, right? Sometimes continuous data always represent measurement, and therefore their value cannot be counted, but they can be measured. There are certain values where you do not want to count the value, you want to measure them, right? And the whole thing which you've seen over here is kind of like when you talk about the data, how you want to talk about the data. So whether the data is qualitative or quantitative. If it is qualitative, what are the two types? If it is quantitative, then it is discrete or continuous. This is one of the most important things which you need to understand. Now if you just describe the whole thing, the variables, it could be of qualitative and quantitative. Then qualitative has got two types and quantitative also have two types. And then there are further classification in quantitative data as well. We're gonna understand them all. Okay. So you have different kind of data wherein you have nominal data. Now what nominal data says that it's majority of the time it is a part of qualitative data, nominal and ordinal, wherein you can have certain variables, label variables, which you want to pick up in order to describe it. For example, male and female, right? They have got no particular order of preference. There is no logical order and there is no particular relationship, right? Wherein I can say I have some male data, I have some female data. The data do not have any kind of relationship with each other, and most of the time they are labels which needs to be converted into mathematical, or I would say numerical placeholders at times, and majority of the time it is qualitative data. For example, I have male and female. I can represent that male as 0 and female as 1, but still that data will remain qualitative. It will not be converted into quantitative. We need it certain at times because our tools doesn't understand what is male or female. For example, I have yes, no data, right? I can say yes for 1, no for 0. I am assigning the numerical placeholders to the qualitative data. I'm not, however, even I'm assigning those numerical placeholder, I cannot take average of them, mind it. So that's why we have called nominal data, which is a part of qualitative data. Then you have ordinal data, wherein you have distinct categories. For example, my rating is poor, fair, good, or excellent. This is called ordinal data. These ratings have got certain order attached to it. They have got certain relationship. However, they cannot be defined in numerical scale. For example, my rating is poor and then fair. I cannot differentiate. I cannot take average of fair and poor, but somehow this data can have certain relationship that poor is not good, right? And fair is better than poor, good is better than fair, and excellent is better than good. So this kind of data is having more information, has got certain relationship between the possible values. However, this is again a categorical data, and it is very difficult sometimes to apply numerical skill to it. Then you have got interval data. It's a set of numerical measurement in which the distance between the number is of known and constant size. For example, if I say there is a particular relationship between the scale, and it also have a constant distance between the numbers. For example, if I say that the temperature is 18 degree centigrade right now, and the temperature is 19 degrees centigrade right now, you will be able to understand that there is a difference of 1 between the temperature, and that's a constant difference, right? So 18 will be 1 degree away than 19 will be 1 degree away from 20, right? So that's a constant difference. And the most important thing about the interval data is that there is no true zero value which can occur. For example, if I say that the temperature is 0 degree right now, it doesn't mean that temperature does not exist, because there is -1 which is also available in that particular temperature scale. So there is no true zero value which can occur in the interval data. Then the last the data type is called ratio. The ratio data consists of numerical measurement where the distance between the numbers is of constant size, and in addition to that there is non-arbitrary 0 point, which means that the 0 has some importance to that particular number. For example, I can say that height of a person is 6 feet, height of a person is 5 feet 11 inch or 6 feet 3 inch. However, I cannot say that the height of the person is 0 feet or 0 inches, because that will not make sense. So there is always a non-arbitrary 0 point which will define the ratio data. However, all these nominal, ordinal, and interval, some of the properties of all these data can be applied to ratio data, but there is always a non-arbitrary 0 point. Now the qualitative and categorical data represent most of the time characteristics. Therefore, it can represent like person's gender, their language, the like how many number of female and male people are there, because you cannot take average of all these, like 3.5 female or 5.7 male people like present in a particular auditorium or in particular class. You can't take average of all of them, and that's where it is one of the crucial topic to understand what is categorical data, because if you kind of understand this, it would be easier for you to apply statistical method or machine learning methods to this, right? So what we're going to understand from in the upcoming tutorial is we're going to understand about the statistics basics, and I'll talk about how, once say you got some data with you and you want to talk about that data, you always wanted to understand what that data says so that you can extract information from it, how you would apply statistical techniques to talk about the data. Once you learn how to talk about the data, it would be like piece of cake for you to apply statistical techniques to it. So in the upcoming session, we'll understand from the very scratch, what is statistics, how statistics is being used to describe the data. I'll see you in the next lecture.